6 subintervals. And taking the sample points to the right, so they want the area basically right 6 decimal places. Okay. We have to start with the interval from 0 to 3 pi over 2. I have to find delta x, which is 3 pi over 2 minus 0 divided by 6. And this is 3 pi over 12. So it's delta x is pi over 4. 1, 2, 3, 4, 5, 6. So this is pi over 4. This is pi over 4, and so on and so forth. So 0 to pi over 4. Pi over 4 plus pi over 4. Pi over 2. 2 pi over 4, 3 pi over 4. 4 pi over 4. 5 pi over 4. And 6 pi over 4. Okay. And they want the right. So the area is delta x in front, f of pi over 4, plus f of pi over 2, plus f of 3 pi over 4, plus f of pi, plus f of 5 pi over 4, plus f of 3 pi over 2. Since the function is sine is 0 here. So you cannot, you don't have to include that, but I'm not going to exclude. I'm just going to put all of them. And of course, I will use the calculator. I will not do this by hand. Stats. Make sure that the mode is in radian mode, otherwise the whole thing will collapse. Then, actually, because the function is just 5 sine x, it won't make any difference. But I have to enter pi's, so it will make a difference unless I enter degrees. But I have pi, so that's fine. So I edit. Okay, the first one, pi over 4. The next one, pi over 2. The next one, 3 pi over 4. The next one, pi. The next one, 5 pi over 4. And the last one, 3 pi over 2. And now I go directly to the top, to the list, and I have in parentheses pi over 4. And then I want sine of list L1. And now I go to stats. I want one variable stats, and I want to calculate the sum of list L2. So the sum is they said 6 decimal places. Okay, so the sum is 0.555360. Is this okay?
I'm checking it out.
Pi over 4 plus another pi over 4 plus another pi over 4 plus another pi over 4. I'm checking. So this is 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2. And they want the right, 1, 2, 3, 4, 5, 6. Pi over 4, pi over 2, 3 pi over 4 pi, 5 pi over 4, 3 pi over 2.
No, they didn't. It still says wrong for some reason.
I don't know what you entered. I can take a look.
I put I didn't put the 0. I put 0.555360.
Yeah, the point should work. Just 0.555360 should work.
Yeah, I'm not sure why. Maybe I'll look at it again after class.
555360. They said 6 decimal places. Did you have 0 to 3 pi over 2? And you had
Yes.
5. So the only difference was 5 sine x and then still 0 to 3 pi over 2.
Right.
With 6 terms. It's very clear. N is 6 subintervals. Taking the sample points to the right endpoints. Round your answer to 6 decimal places. So when you enter 0.555360, it said it was wrong.
Yes.
Okay, let me take a look and see what you entered. I mean, I trust you. I'm just saying. Oh, of course, I'm logged out. Anybody surprised? No.
What section was this again?
This was for the Riemann sum 5.2. Let me check. Yes, 5.2, yeah.
Problem 2.
Thank you.
Okay, I'm logged out. I have to start from scratch. Sorry about that. Okay, finally. Okay, putting in my password now. Okay. Almost there. I'm going to the class. Okay. Okay. And we're looking for 5.2. 5.2. Okay, finally, I'm clicking on 5.2. And we said it was problem 2.
Would it make sense to try and solve it using we'll call it the Riemann sum notation, just instead of n to infinity, n to 6?
No. So hold on just 1 second. Where is my, okay. So it was indeed 5 sine and indeed 0 to 3 pi over 2. That's correct. And it says 6 terms. 6 terms is very clear. And we are using the right endpoints. 1, so from 0 to 3 pi over 2. 3 pi over 2 minus 0 divided by 6. So this is 3 pi over 2 divided by 12. So this is pi over 4 in front. F of pi over 4, f of pi over 2. Maybe I should do this calculation one more time. Let me do the calculation one more time. Maybe I didn't enter something correctly. It's always possible. Okay, so of course this was 0 as expected. So let me enter these numbers one more time. Okay, so we wanted pi over 4. Watch and make sure I don't make an error there. Then pi over 2. And then 3 pi over 4. 3 pi divided by 4. Then pi. Then 5 pi over 4. Maybe I didn't click on 5. And 3 pi over 2. Okay, good. So now I go back up to, oops. So this is outside pi over 4, pi divided by 4, close. And then we had 5. Yes, 5 sine of list L1, close and close. I think I forgot to put the 5. That's what happened. I did not put the 5. I clicked, but I didn't. I'm pretty sure. I'm pretty sure. We'll see in a moment. So then I go to stats and calculate. Oh, yeah. I did not put the 5 in front. My apologies. So it's 2.776802. Careful. So 2.776802. So if you'd like to enter that, my apologies. I did not put the 5 in front. That's what it was. It was 5 sine x. Does it work?
I'm with you. I'm typing it in now.
Okay, perfect. Let's work on another problem. Anyone else would like to work on or suggest a problem?
Yeah, could we do something from rates? Another one?
Which one?
I was wondering if we do another related rates problem.
Okay,
I don't have anything particular in mind.
okay. And what was Cameron? What did you have in mind?
3.4 web assign into chain rule 1. I
Yes.
can copy the equation into the
Okay.
chat.
Did it work?
Yes.
Okay, awesome. Yeah, I'm so sorry. I forgot. Everything is correct, but when I entered the function, I didn't enter the 5 in front. And then made, of course, a huge difference. So do we have that? Okay. So we have, is it R of t? And is it 7 raised to 2 the square root of t?
Yes, exactly.
Okay, and what we are asked to differentiate?
Yes.
Okay, perfect. So r prime of t, so remember when we have e to x prime, it's e to x. But if we have a to x prime, we have a to x times natural log a. So here's my first thing I need to do. Remember that I'm differentiating 7 to a function. So I have to write 7 to that function times this function prime, because I just chose x, it would be 1. This function prime, so 2, 1 over 2 the square root of t times natural log 7. I will simplify the 2 with the 2. So then I have r prime of t is, I'm thinking how to write it as easy as possible, but I don't think there is a way. Natural log 7 over the square root of t. Is this okay?
Yeah, thank you.
Perfect. So we want to look at another related rates. Related rates. I'm looking through the book. Related rates are 3.9. We did the particle. We did the particle. We did the cone. Yeah, what about 21? Let's see. Oh, I meant to look at the book, actually. So 3.9. The altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 centimeters squared, of course, because it's area, per minute. At what rate is the base of the triangle changing when the altitude is 10? And the area is 100, 10 centimeters and 100 centimeters squared. Is this something that interests you?
Yeah, that looks interesting.
Okay, let me put the book away. Good. Okay, we're on page 10. Good, so 21 and 3.9. So we have a triangle. The altitude, which is this, the height, is increasing at a rate of 1 centimeter per minute. So dh over dt equals 1 centimeter per minute. While the area of the triangle is increasing, so the area, dA over dt equals 2 centimeters squared per minute. At what rate is the base of the triangle? So I'm going to call this uppercase B. So dB over dt is how much when h is 10 and a is 100. Okay. Oh, sorry, I see that. I saw that. Good. So we know that the area of a triangle is the base times the height divided by 2. Now, again, if this helps you, remember that all these are functions of time. Put a little dot next to it so you don't make an error. So then when we differentiate both sides, we have dA over dt equals 1/2. So this is the product rule. dB over dt times age plus, I'm going to erase this, plus B times the age over dt by the product rule. Okay, so all I have to do now is ask myself, what do they want? They want us to determine the dB over dt. Fine. I will distribute 1/2. I get the following equation, dA over dt equals 1/2, or age over 2 better, dB over dt plus B over 2, the age over dt. And this is the variable in question. So I'm going to move this to the other side and then divide by age over 2. So dA over dt minus B over 2, the age over dt equals age over 2, dB over dt. dB over dt will be this whole thing over age over 2. The A over dt minus B over 2, the age over dt. And now, when age is 10 and A is 100, as you know, this is the trap. If you put it in from the beginning, they're not going to get anything. So we're plugging it in. So then dB over dt, and this will be in centimeters per minute. dA over dt. dA over dt is 2 minus base. Base has to be determined. So I'm going to just write B over 2 for now. The age over dt, 1 over age over 2, which is 10 divided by 2, which is 5. Okay, now, when this happens, so the area is 100, and the area is base times height divided by 2, and I have age which is 10, I have to determine B that I need here. So 100 equals B times 10 divided by 2. I simplify, and this is 5. B will be 100 divided by 5, which means B equals 20 centimeters when age is 10 centimeters and area 100. So I will plug it in. So then finally dB over dt is 2 minus 2 So I'm checking my numbers, 100 B times base times height divided by 2. I simplified, I got 5. So this is 20. Let's read a question, because I'm getting a rate which is, at what rate is the base of the changing? So they're not telling us. So I'm assuming it's decreasing. Okay. I just need to make sure. It doesn't say, but I'm getting a negative number, which is possible. I'm not saying it's wrong. I'm just saying I'm getting a negative number, and I have to make sure that everything is correct. I'll go back and check everything. So then 2 minus 20 divided by 2 is 10 divided by 5. So this is negative 8 over 5. And this is in centimeters per minute. It only means that it's decreasing at this rate. So 8 divided by 5, 8 divided by 5, 1.6, correct. So this appears to be negative 1.6 centimeters per minute. So when I'm trying to picture this, when the height is increasing, then the base is decreasing. I'm trying to picture and make sure that everything. Say it again. Go ahead. Yes, Cameron? You wanted to say something? Hello? Cameron, did you want to say something? I thought I heard something. Okay, I'm not sure. Okay, so I'm gonna make sure it's increasing. Okay, the area of the triangle is increasing at a rate of this. At what rate is the base of the triangle changing when the altitude is 10 and the area is 100? So I'm checking myself again. This is correct. This is correct. dB over dt. Area is base times height divided by 2. I differentiate the left-hand side. I kept 1/2 in front. dB over dt times h plus b times dh over dt. Then I distribute it. H over 2 dB over dt plus b over 2 dh over dt. Correct. Then I moved this piece to the other side, minus b over 2 dh over dt, correct? H over 2 dB over dt, correct. So then this is all this divided by h over 2. Perfect. H over 2 is 10 over 2, which is 5. This is given to us to be 2. This is given to us to be 1, dh over dt. Yes, it's 1. Once I know that the area is 100 and the height is 10, then I have to determine b. So 100 equals b times 10 over 2. This is 5. I divide both sides by 5 and I get 20. So then I have 2. 20 divided by 2 is 10 minus 8 over 5, and I stick by my answer. Any questions?